Picture a Thursday afternoon roughly 70,000 years ago. You are one of approximately 1,000 human beings alive on the entire planet. Not in your region, not in your continent, on Earth. All of it. Every human who exists anywhere, from the southern tip of Africa to wherever the furthest wanderer has reached, adds up to roughly 1,000 people. Some estimates say as few as 40 breeding pairs. The total human population fits inside a mid-sized modern apartment complex. The volcano responsible for this situation, Mount Toba in what is now Sumatra, erupted approximately 74,000 years ago in what geologists classify as a super eruption, the largest volcanic event in the last 2 million years. It ejected somewhere between 2,500 and 3,000 cubic kilometers of material into the atmosphere. For comparison, the 1980 eruption of Mount St. Helens, which killed 57 people and flattened forests across a vast area, ejected about 1 cubic kilometer. Toba was 3,000 times larger. The resulting volcanic winter lasted years. Global temperatures dropped. Vegetation collapsed across enormous regions. The food chains that human populations depended on fractured from the bottom up. Whatever the precise death toll, and we will never know it, the genetic evidence in every human being alive today tells the same story. At some point in the relatively recent past, the human population passed through a bottleneck so severe that the entire modern human species descends from a population smaller than what you'd find at a neighborhood barbecue. And then those people, those few hundred or thousand survivors huddled in refugia in southern Africa, potentially near coastal areas where marine resources buffered the ecological collapse, did something extraordinary. They didn't just survive, they recovered. They expanded. They eventually populated every habitable environment on Earth. They became us. So how? How did a population so small that a single bad flu season could have erased the species entirely pull back from the absolute edge of extinction and claw its way to 8 billion descendants? The answer involves biology, behavior, social structure, technology, and a set of cognitive capabilities that were already in place before the catastrophe hit. Capabilities that, under ordinary circumstances, were advantages, but under existential pressure, became the difference between extinction and everything that came after. Start with what the survivors had that most other large animals in equivalent situations did not: a brain wired for cumulative culture. Cumulative culture is the ability to take a solution someone else discovered, build on it, improve it, and pass the improved version forward, so that each generation inherits not just the knowledge of the previous generation, but an incrementally better version of that knowledge. A chimpanzee can learn to use a stick to extract termites from a mound by watching another chimpanzee do it. But chimpanzees don't meaningfully improve on the technique across generations. The stick tool of a chimpanzee group today is functionally the same as the stick tool their ancestors used hundreds of thousands of years ago. Human technology doesn't work this way. A human group that discovers fire can teach the next generation not just how to maintain fire, but how to create it more reliably. That generation adds improvements. The generation after inherits those improvements and adds more. The ratchet clicks forward, and it doesn't click back. For a population of 1,000 people facing the aftermath of a supervolcanic winter, cumulative culture meant that every survival solution ever discovered by anyone in that population, every technique for finding water in a landscape where water was scarce, every method for preserving food through lean periods, every approach to constructing shelter against temperature extremes, every piece of knowledge about which plants were edible and which were toxic was potentially accessible to everyone. The survivors weren't starting from scratch. They were drawing on a library of accumulated solutions that had been building for tens of thousands of years before the catastrophe hit. The group's collective knowledge was the most important survival resource it possessed. More important than tools, which can be lost or broken. More important than territory, which can be abandoned. Knowledge, encoded in language and transmitted through teaching, travels with the people, who carry it. and can be reconstructed even after devastating losses. Language itself deserves examination as a survival technology, because the version of language that modern humans possess is qualitatively different from the communication systems of any other species, and that difference was operationally critical for a bottlenecked population. Human language allows the transmission of information about things that are not present. Events in the past, objects in other locations, hypothetical futures, abstract concepts. A vervet monkey can produce alarm calls that distinguish between aerial and ground predators, which is remarkable and useful. But a vervet monkey cannot tell another vervet monkey about a water source 3 days' walk to the east that might be worth checking if the local sources dry up. It cannot describe the route. It cannot explain what the terrain looks like on the way. It cannot warn about the territory of a rival group that the route passes through. A human can do all of these things in the time it takes to eat lunch. For a small population scattered across a landscape devastated by volcanic winter, the ability to share precise spatial information, to coordinate across distances, to plan provisionally for conditions not yet encountered, to pool knowledge about resources neither currently visible nor immediately accessible, this was not a luxury cognitive feature. It was survival infrastructure. The humans who made it through the Toba bottleneck were the descendants of populations that had already developed this capability, and they deployed it relentlessly in the reconstruction of viable life from the wreckage. Social structure mattered enormously, and the social structure of human hunter-gatherer groups turns out to be remarkably well engineered for resilience in exactly the conditions the survivors faced. Hunter-gatherer bands typically numbered between 20 and 50 individuals, what anthropologists call the band level of social organization. This is a number small enough for every member to know every other member personally, for trust relationships to be maintained without formal institutions, and for the group to be mobile enough to track resources across a varied landscape. A band of 30 people can make a collective decision to move and execute that decision in a day. A city of 1 million cannot. But human social organization doesn't stop at the band. Hunter-gatherer peoples maintain what anthropologists call the tribal level, a network of bands who share language, cultural identity, and mutual obligation, typically numbering between 150 and 2,000 individuals. These bands interact periodically, exchange members through marriage, share information about resources, provide assistance during crises, and maintain the social connections that allow a devastated band to seek refuge with a neighboring band rather than simply dying. This multi-level social structure was, for the Toba survivors, a network architecture designed for exactly the kind of cascading crisis they faced. When a local band lost members to starvation or disease, survivors could be absorbed by neighboring bands. When a local territory became unviable, the band could move and call on obligations established through years of reciprocal exchange with groups in other territories. When critical knowledge was lost with the deaths of the individuals who carried it, the network connections to other groups offered potential access to equivalent or alternative knowledge. Humans are not the only social animal, but the combination of band-level intimacy and tribal-level network, the ability to maintain deep personal trust relationships within a small group while simultaneously sustaining a much larger network of looser but still meaningful social obligations, is a structural feature of human sociality that appears early in the archaeological record, and that provided exactly the kind of redundancy a bottlenecked species needed to survive. Now consider the role of kinship systems and marriage practices in post-Toba survival, because this is where things get both anthropologically fascinating and strikingly practical. A population of 1,000 people has a serious genetic problem. Inbreeding, the mating of closely related individuals, accumulates harmful recessive mutations in offspring and reduces the genetic diversity that allows populations to adapt to changing conditions. In a population of 8 billion, finding Elasai Swarisata, unrelated mate, is trivially easy. In a population of 1,000, concentrated in small bands, each of which knows everyone else personally, the risk of mating with close relatives is substantial, and the genetic consequences are severe. Hunter-gatherer kinship systems, observed in contemporary and historically documented populations, show a consistent and elegant solution to this problem: exogamy, the practice of requiring marriage outside one's own group. In virtually every documented hunter-gatherer society, marriage within the immediate band is prohibited or strongly discouraged. Mates must be sought from other bands in the tribal network. This practice, which appears so deeply embedded in human social organization that it may predate the Toba event itself, accomplishes several things simultaneously. It prevents inbreeding and maintains genetic diversity. It creates alliances between bands. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. The marriage of a man from Band A to a woman from Band B creates kinship obligations between those bands that function as a formal mutual aid agreement. It spreads individuals with particular skills across the network. If Band A has an exceptional toolmaker whose daughter marries into Band B gains not just a family member but potentially access to that toolmaking knowledge. For a population of 1,000 struggling to maintain genetic viability while rebuilding numbers, exogamy was not a cultural nicety. It was a genetic survival strategy so effective that it may have been one of the key mechanisms preventing the post-Toba population from collapsing into the inbreeding depression that dooms so many small wildlife populations facing similar bottlenecks. The geography of the Toba aftermath matters enormously, and the archaeological evidence points towards something that looks, in retrospect, like remarkable strategic positioning, even if it was accidental. Southern Africa, and particularly the coastal regions of what is now South Africa, appears to have been one of the primary refugia where humans survived the Toba winter. The coastline provided something inland environments devastated by volcanic ash could not: a food supply insulated from the terrestrial ecological collapse. Marine resources: shellfish, fish, marine mammals, seabirds, and their eggs. The ocean was not unaffected by the volcanic winter, but coastal marine ecosystems proved more resilient than the terrestrial food webs that most large mammals depended on. The archaeological sites along the South African coast, Blombos Cave, Pinnacle Point, Sibudu, preserve evidence of sustained human occupation through the period of the Toba aftermath, and the assemblages found there tell a story of remarkable behavioral sophistication. Ochre processing. Pigment preparation implying symbolic behavior. Engraved geometric patterns. Possible early evidence of abstract symbolic communication. Sophisticated bladelet technology. Small, sharp stone tools that could be hafted into composite weapons. Shellfish middens representing sustained marine resource exploitation. Evidence of fish trapping, of systematic plant use, of the kind of broad-spectrum economic strategy that characterizes populations squeezing maximum caloric yield from a challenging environment. These people were not simply surviving. They were innovating under pressure. The behavioral modernity that archaeologists have long debated as emerging suddenly or gradually in the human record appears, at sites like Blombos, to have been developing in exactly this crucible. Small populations under intense selective pressure in coastal refugia, where the cognitive flexibility and behavioral innovation that characterize modern humans may have been sharpened by exactly the existential stakes the Toba event created. Pressure produces adaptation. It also, sometimes, produces breakthroughs. Food storage technology, often overlooked in discussions of early human survival, deserves significant attention because it changes the fundamental equation of small population survival in a resource-variable environment. A group that eats what it finds when it finds it is perpetually vulnerable to the variability of the natural world. A good day in a good season produces surplus that cannot be carried forward. A bad day in a bad season produces deficit that the bodies of group members must absorb. The ability to carry surplus forward in time, to eat abundantly when resources are rich, and draw down stored reserves when resources are scarce, fundamentally stabilizes the caloric floor beneath which a small population risks mortality. Evidence for early food storage in the archaeological record is fragmentary but present. Dried plant material, smoked or dried fish and meat, seeds cached in containers. The specific techniques varied by environment. Coastal populations had different preservation opportunities than inland savanna populations. But the underlying principle of temporal smoothing of caloric availability through storage appears early in the human behavioral record. For a post-Toba population, food storage technology had an additional dimension beyond individual band survival. Stored food is portable wealth, a resource that can be shared, gifted, or exchanged across band boundaries in ways that maintain the social obligations underlying the tribal network. A band that arrives at a periodic gathering of multiple bands with stored food to contribute participates in the reciprocal exchange that keeps the network functioning. A band that arrives with nothing to offer is socially disadvantaged in exactly the ways that matter most when crisis hits and you need your network to respond. The social economy of stored food, the way surplus became a medium of alliance maintenance, may have been as important as its direct caloric contribution to post-Toba survival. Fire management at this point in human prehistory was already ancient technology, but its role in the survival of small populations facing the aftermath of volcanic winter was multidimensional in ways worth unpacking. The obvious contributions are clear: warmth in a cooling world, cooked food with improved caloric extraction and pathogen reduction, predator deterrence enabling camps in open environments that would otherwise be too dangerous. These were not trivial. A population of 1,000 facing a volcanic winter without fire would have faced substantially higher mortality from cold exposure, foodborne illness, and predation than the same population with fire. But fire did something else that gets less attention. It restructured time. The campfire extended the usable day past sunset, creating hours of warmth and light during which social activities, tool production, food processing, and critically, communication could occur. The evening around a fire is where stories get told, where knowledge gets transmitted, where the young learn from the old, where plans get made and problems get collectively solved. Anthropologists studying contemporary hunter-gatherer societies have noted that evening campfire time is disproportionately allocated to storytelling, myth-telling, and the transmission of cultural knowledge, dramatically more so than daytime conversations, which are dominated by practical task coordination. The campfire was, in effect, the classroom, the library, the planning session, and the social bonding ritual all in one daily recurring event. For a bottlenecked population where the loss of any single elder represented the permanent loss of whatever knowledge that person uniquely carried, maximizing the frequency and quality of knowledge transmission was existentially critical. The campfire created a daily structure for doing exactly that. Cognitive flexibility, the ability to shift behavioral strategies rapidly in response to novel challenges, was perhaps the deepest advantage the human survivors possessed, and it expressed itself in the archaeological record through what researchers call dietary breadth expansion. When primary food resources collapse, a generalist species can pivot to secondary and tertiary resources. A specialist cannot. The Toba aftermath created exactly the conditions where the extraordinary dietary breadth of Homo sapiens, our willingness and ability to eat an enormous range of foods from an enormous range of environments, became a decisive survival advantage over more specialized fauna that shared our refugia. The archaeological evidence from coastal southern Africa shows humans exploiting essentially everything available: large shellfish, small shellfish, fish, marine mammals, tortoises, small mammals, birds, plant tubers, seeds, fruits, insects. The dietary profile is not that of a population with preferred foods and fallback options. It is the profile of a population systematically extracting calories from every available source simultaneously, with the cognitive and technological flexibility to exploit whatever the environment currently offered rather than depending on a narrow range of preferred resources. This dietary generalism was the behavioral expression of a cognitive architecture built for flexibility. The same brain that could pivot dietary strategy in response to ecological collapse could also pivot social strategy, territorial strategy, technological strategy, could, in short, solve novel problems rather than only efficiently executing solutions to previously encountered problems. The populations that went extinct in the Toba aftermath were not necessarily less intelligent than the survivors. They were, in many cases, more specialized, more dependent on particular food webs, particular ecological niches, particular behavioral strategies that worked brilliantly under ordinary conditions and catastrophically under extraordinary ones. Specialization is efficiency. Generalism is resilience. The Toba event was a brutal selection event in favor of resilience. And Homo sapiens, already the most behaviorally flexible large mammal on the planet, was already positioned to pass the test. There is a detail in the genetic record of the human bottleneck that tends to get glossed over in popular treatments, and it deserves attention because it changes the emotional texture of this story considerably. Geneticists studying the Toba bottleneck note something that seems, at first, paradoxical. The bottleneck was severe enough to reduce human genetic diversity dramatically. We are, as a species, remarkably genetically homogeneous compared to other great apes. A single population of wild chimpanzees in Central Africa harbors more genetic diversity than the entire human species. This is the genetic signature of a near-extinction event. But the population that came through the other side was not a random sample of the pre-Toba human population. It was a selected sample. The individuals who survived and successfully reproduced in the aftermath of the most catastrophic environmental event in human history were, by definition, those whose particular combination of physical robustness, cognitive flexibility, social competence, technological capability, and perhaps sheer luck allowed them to function effectively under conditions that eliminated everyone else. Every human alive today is descended from the winners of the hardest survival test the species ever faced: the cognitive capabilities we take for granted. Language, cumulative culture, social flexibility, behavioral innovation. The ability to plan across time and coordinate across social networks were present in the pre-Toba population. But the Toba event may have functioned as a crucible that concentrated those capabilities in the surviving population, stripping away individuals and lineages where those capabilities were less developed, leaving behind a founder population that was, in some meaningful sense, more behaviorally modern than the average pre-Toba human. The population bottleneck may have been, paradoxically, an accelerant of the very behavioral modernity that allowed the survivors to expand from 1,000 individuals to 8 billion descendants in roughly 70,000 years. The expansion that followed the bottleneck is, in its own way, as remarkable as the survival itself. Because it happened fast. Extraordinarily fast by evolutionary standards. From a founding population of perhaps 1,000 individuals in southern African refugia, modern humans reached the tip of South America within 70,000 years. They crossed open ocean to Australia. They survived the Arctic. They adapted to tropical rainforests, high-altitude plateaus, desert environments, subarctic tundra. They did not speciate into populations optimized for each environment the way other organisms do over comparable timescales. They adapted culturally, inventing appropriate clothing, shelter, food technologies, and social strategies for each new environment as they encountered it. The key to this expansion was the same toolkit that survived the bottleneck. Cumulative culture meant that successful adaptations to each new environment were preserved and built upon rather than reinvented from scratch each generation. Social networks meant that groups expanding into new territories maintained connections with groups they left behind, creating information flow and genetic exchange across vast distances. Language meant that knowledge of new environments could be shared with precision and detail that no other species could achieve. The 1,000 survivors of Toba carried in their behaviors and their social structures and their cognitive architecture a complete survival system. Not a perfect one, not one that prevented hardship, death, or tragedy, but one robust enough, flexible enough, and self-improving enough to eventually fill every habitable environment on Earth. There is something worth sitting with at the end of this story that goes beyond anthropology or genetics or archaeology. Those 1,000 people, or 40 breeding pairs or whatever the precise number was, had no idea what they were. They had no concept of being the last members of a species on the edge of extinction. They didn't know about genetics, about bottlenecks, about the significance of their survival for the 8 billion people who would eventually descend from them. They were cold and hungry and frightened and trying to feed their children and maintain their social bonds and find water in a landscape that the sky had broken. They did what humans do. They gathered around fires. They told each other stories. They shared food. They remembered where the good shellfish beds were and passed that knowledge to the younger members of the group. They arranged marriages between bands. They mourned the people who didn't make it and honored them in whatever ways their cultural tradition provided. They got up the next morning and went looking for food. The scale of what they accomplished is invisible from inside it. The everyday business of human survival, conducted at the edge of extinction, produced a recovery so complete that 70,000 years later, a species of 8 billion people can sit somewhere warm and comfortable and try to reconstruct what it must have been like. The apartment complex of humanity, clinging to survival in a world the mountain had broken, did not know it was writing the opening chapter of the most improbable success story in the history of life on Earth. They just kept going, which it turns out was exactly enough.